Welcome to the Space Explorers podcast, where we take a deep dive into the fascinating world of astrodynamics and modern space technology. I'm your host, and today we're exploring an intriguing development in the realm of space mission planning, the LOX library. So, what exactly is LOX? Well, LOX is an astrodynamics library designed specifically for the contemporary space industry. It's currently under active development, which means it's not yet in a stable release, and its interface could evolve. But that's part of what makes it exciting. Imagine the possibilities as it grows and matures. Now, what makes LOX stand out? For starters, it offers a comprehensive astrodynamics API that caters to both seasoned experts and newcomers alike. At its core, there's a high-level interface called lox-space, tailored especially for mission planning and analysis. But if you're more of an advanced user, you can dive into specific crates like lox-time, lox-earth, and lox-orbits for a more granular approach. I find that incredibly compelling. With LOX, you have the power of a fully featured space mission simulator backend right at your fingertips. And it's not just limited to space enthusiasts. It's got Python bindings for those who prefer interactive use, which opens it up to a wider audience of developers. Imagine having the tools to work with time across both astronomical and terrestrial timescales. That's pretty mind-boggling. Speaking of time, time in space is not just abstract. It's essential, right? The LOX time crate is all about working with commonly used astronomical timescales. It even accounts for leap seconds. You know, those pesky adjustments that make sure our clocks stay in sync with the Earth's rotation. It's a brilliant utility, especially if you think about it in the context of planning a space mission. And it doesn't stop there. LOX also provides data for all major celestial bodies. The LOX Bodies crate categorizes these bodies based on various traits and uses SPICE-derived data. You could practically conduct a thorough analysis of all the planets and moons that intrigue us so much. Oh, and let's not forget lox-earth, which is crucial for Earth-centric astrodynamics. This section includes algorithms for models like nutation and precession, which may sound complex but are crucial for anyone working on space navigation. If you're wondering about how all this data ties together, look no further than lox-ephem. It parses ephemeris data from external sources, such as SPICE kernels, and lox.io, which provides utilities for reading and writing data in various formats. It's like the Swiss Army knife of astrodynamics. Now you might be wondering, why the name LOX? Well, it's actually inspired by liquid oxygen, a key component in rocket propulsion. The term LOX has a rich history in aerospace, dating back to Robert H. Goddard's groundbreaking work in liquid-fueled rocketry. So the name itself pays homage to the innovations that have brought us to where we are today in space exploration. As we wrap up today's episode, it's fascinating to think how tools like LOX will shape the future of space missions. With its extensible nature, users can bring their own timescales and transformation algorithms, a testament to the collaborative spirit in the programming and space communities. So, whether you're an aspiring astronaut or just curious about the cosmos, LOX holds exciting potential for everyone interested in the final frontier. If you could create your own mission to any celestial body using LOX, where would you go and why? Think about that, and maybe dive into LOX yourself. Thanks for tuning in to the Space Explorers podcast. We hope you learned something new and inspiring today. Until next time, keep looking up